Number 9, we're basically going to determine if a function is even or odd. One other type of symmetry is symmetry with respect to the origin. Now, I'm going to take a paper clip and I'm going to bend it to show you the symmetry of an odd function. So, graphed here in my textbook, and let me zoom in just a little, is f of x equals x squared. And what we're going to do is show how it's symmetrical. So if I take this paper clip and I hold it onto my textbook and I try to make it look like this one particular portion of the graph. So this is not easy to do with a paper clip. It'd be easier to do with some string, but I left my string in the other room. Well, maybe I could draw it. Let's draw it. So if I draw from here to here, and I come around and I draw this line, okay? Now, when we say symmetrical about the axis, if I select this, okay, and I flip it up once, in other words, I flip this up this way, whoops, it won't let me flip it up. Well, it did. I flipped it up, but now I got to move it. If I flip it up like that, right? And then I'm going to flip it over the other way. This is so much easier to do on the smartboard. And I flip it twice. In other words, I flip it over the x-axis and I flip it over the y. What do you notice? They're the same thing. Now here the pattern repeats, but when the pattern repeats you have positive values and negative values. So here we have the pattern negative 27, negative 8, negative 1. Now when the pattern repeats it's positive 1, positive 8, and positive 27. Now I've already taught you guys this once before, but this is f of negative x is equal to the negative of f of x in an odd function, where if we were to look at the even functions, no matter if we plug in negative 1 or negative 2, it didn't matter, we got the same y value. Does that make sense? You guys have any questions about that? So what we're going to do now is if we look at number 9, we're going to check for function symmetry, and that will determine if something's odd or even. So this is simple. We're just going to plug these into the calculator and then look to see if they're odd or even. So my first one that I'm going to plug in is x squared minus 3. Now, is that symmetrical about the y-axis? Yeah, so what should that be? Even. Now, when we go in and we look at the table of values, the pattern repeats, right? When x is negative 3, y is 6. Well, guess what? When x is positive 3, y is 6. Do you see that? And the pattern repeats itself. 6, 1, negative 2, negative 3, which is the vertex, negative 2, 1, 6. And if I were to stretch that out and we were to look at all these values, the pattern would repeat in both directions forever. Does that make sense? Okay, good. So that one is even. Now let's do the next one. The next one is g of x is x squared minus 2x minus 2. Uh-oh. Is that symmetrical about the y-axis? No. Is that symmetrical about the origin? No. So that's probably going to be neither. Now we could clear this up by looking at the table of values. When I plug in negative 3, I've got a positive 13. However, when I plug in positive 3, I've got 1. If I had a negative 13, I would say it's an odd function. If I had a positive 13, I would say it's an even function. But I can't say it's even and I can't say it's odd, so it is neither. Does that make sense? Now this next one is x cubed over 4 minus x squared. So let's plug it in and see what we get. So we're going to have x cubed divided by the quantity, 4 minus x squared. Let's see what we get. Graphing. That looks symmetrical about the origin. How could I double check? By the way, if it is symmetrical about the origin, what do we call that? Even or odd or neither? Odd. So if I look at the table of values, basically when I plug in a negative 3, I get positive 5.4. When I plug in a positive 3, what do I get? Negative 5.4. Here, when I plug in a negative 1, I get negative 0.3 repeating. When I plug in a positive 1, I get the opposite, which is 0.3 repeating. So this is an odd function, okay? This is an odd function. Does that make sense?